keeping humans a part of deep learning. I'm Tonya Hall, and joining me is Jeremy Howard, founding researcher at Fast.ai. Welcome, Jeremy.
Nice to be back.
So, again, a refresh, you guys do some really interesting work at Fast.ai with some really good intentions to help society. Talk a little bit about your work and what prompted you to start the company.
Sure. So we're a self-funded lab. We're not really a business. We don't have kind of revenue or anything. We spend our money trying to build things that we think will help allow people to use artificial intelligence more easily, so that we find it's not exclusively in the hands of a small exclusive group of people who have all done, machine learning PhDs at Stanford or whatever, but it could actually be used by normal folks. We provide education, we write software, we do academic research, and we even provide a very popular online community for folks to get together and hopefully bring AI to the rest of the world.
Jeremy, we talk a lot about artificial intelligence and how wonderful it is and how much it's going to change our lives and how great the future is going to be. But what are the things that humans do better than AI? And where do AI driven machines excel over humans?
Sure. So at the moment, artificial intelligence, and particularly an algorithm called deep learning, which is the algorithm that powers nearly all artificial intelligence today, is actually as good as or better than humans at some things that might feel pretty human. So for example, if you take a photo and say, what's this a photo of? Then a lot of the time, machines will be better than humans. If you have some audio, some speech audio, and you say, what did the person just say? Then in a lot of situations, a computer will be able to do a better job than a person at recognizing at least Chinese and English. So certainly AI has come a long way, specifically deep learning has come a long way. And it's moving also very quickly. So anything that last year humans were better at, maybe this year things have changed, or next year things have changed. But humans are significantly better at machines at a number of really important things, particularly around dealing with like what I call like common sense, like looking at some um, outcome and saying, is this reasonable? You know, and so and kind of being able to bring in our whole knowledge and experience of the world, because an AI algorithm has no experience of the world. It's never gone swimming. It's never eaten a hamburger. It's never felt hot. So it doesn't really have this ability to kind of say, like, this situation makes no sense in the same way that people can. Also, algorithms are still not on the whole good at kind of big picture strategizing, and they're also not at all good at dealing with very unusual situations. So like maybe you've got some algorithm that trades the markets, and there's a once in a generation crash, and that algorithm is going to have trouble predicting that or understanding what to do about that when it happens, because it's dealing with the millions of data points it sees every day. Those are a few examples. Another really important area is around human interaction, where like the actual humanity is important in and of itself. So for example, if you are going to see a personal trainer and you just need somebody to kick your butt a little bit, or you just need somebody to like give you a bit of tough love or whatever, a- an algorithm can say exactly the same things as a person, but it doesn't really mean anything. Or a musical performance. You could see a machine moving a bow over a violin in exactly the same way as a person, but it's not going to do anything for you. Like, there are a lot of things in the world where the fact it's a human doing it, is what matters. Like, I would never want to go and see a tennis match played by robots. It just wouldn't be an interesting spectacle. It's the thing that makes it interesting is to go like, wow, Roger Federer is an amazing human being. I couldn't do that. So there's certain things in the world which actually require the human touch for it to be of any interest at all.
So, how do machines learn, and why do we need to consider humans in machine learning?
Sure. So when we say machine learning, what are machines learning from? They're learning from data. So for example, when we create an algorithm that can look at a photo and say, that's a picture of a frog, that's a picture of an airplane, we do that by providing it lots of pictures of frogs and airplanes and so forth, and labels. This is a frog, this is an airplane. And after a while, it figures out what's what and it learns to recognize them by itself. The um, the choice of images and labels you give to that algorithm matter a lot. So in one famously awful example, um, Google trained their algorithm in which very, very few of the people faces that they showed the algorithm were black faces. And so in the actual Google Photos app, a black customer had a selfie with his wife and Google's algorithm labeled it gorilla. So your decision as to what data you feed that algorithm impacts, the customer experience. It impacts the thing that comes out the end. So there's this kind of like important curation of what product are you building, what data do you put into it. Also, a lot of these algorithms require a lot of data. And so one of the things you can do to make it much faster and cheaper to build a data product in these areas is to be very thoughtful about providing the right kinds of data. So actually what tends to work best is if you can kind of create an interface where the human and the computer can help each other out. So the computer can say to the human, hey, here are some photos which I'm having trouble recognizing. And then the human can say, okay, I'll tell you what they are. And then the computer can then use that to train up some a little bit more and then say to the human, okay, I get it, but here are some other ones now I'm having some trouble recognizing. So one of the things that I think is really missing at the moment in AI, in research and in products, is a focus on bringing what humans are good at and what computers are good at together and combining them.
Why do you say that most research in deep learning right now is a waste of time?
Well, this may be true of research more generally, I don't know, but my particular field is deep learning. And when you look at how the academic industry works, if you want to get a tenure position job, which is what pretty much all academics do, you have to get good metrics. You've got to get these numbers next to your name that say things like, I've published lots of papers, and then and they're in journals that have high impact scores. And then lots of people have written their own papers and cited my paper, so said that my paper was important in helping them with their paper. So citations and publishing is kind of the equivalent of like sales in normal businesses. So how do you get something published? Okay, so the next question is, how do you get something published? So how do you get a conference or an academic journal to decide out of the thousands of applications that your research is something that they're going to include? Well, what happens is it gets sent out to your peers. It's called peer review. And so other people in your area of academia will say yes or no that I think this should be published. So there's a lot of problems with this. If you're trying to do breakthrough research, like working on a problem that just no one's really thought about before, you're going to have a lot of trouble even finding a peer group that would say that should be published, because there isn't really a peer group of people who understand why this is an important problem or would recognize whether you've made a contribution there. So what tends to happen is if you want to get published, you instead find the topics that the people who are likely to review your paper are already writing about, and you write about them too. And then you try to make a tiny little increment so that then the people that are your academic peers will go, oh, I understand this paper. And it's a slight improvement over what we had before. So yes, we should publish it. And so then to get citations, so to get other people then to take your paper and say, oh, my paper was somewhat based on that paper, they then they then need to ensure that, if your paper is, again, if it's off the wall, if it's weird, if it's not the same stuff everyone is doing, you're not going to get citations because nobody else is writing about your same field. So if you're doing actual breakthrough research, you know, brand new areas that people just haven't really thought about before, you ain't going to get tenure because you're not going to get published and you're not going to get citations. And everybody knows this, right? Like they're like at university, um, your teachers, your supervisors will tell you, here's all the dirty secrets about how to get published. And so as a result, we have all this, like, I don't know, kind of dull, homogeneous papers in the deep learning community, at least, which, um, so many of them, if they weren't published, nobody would care. It really would make no difference whatsoever.
So, Jeremy, how do you see machine learning progressing in the near future, 12 to 18 months? Will it be incremental creep forward, or are we likely to see a disruptive method or technology change everything? And what role will humans play in that either way?
So we're at an interesting point in machine learning at the moment, which is this particular algorithm called deep learning has turned out to be so incredibly flexible and so incredibly scalable that nearly everything that people throw it at, it just turns out to blast everything else out of the water. And um, there are still very few people that know how to use this technology. So this is why Fast.ai exists, is to change that, is to make it so lots of people do. But there's maybe 100,000 people have done our course, but that's still lots of people that haven't, right? Um, so there's still the vast majority of the space of like things that deep learning will kind of totally change is still vast. We still just scratch the surface. So I think the next 12 to 18 months is going to continue to be um, amazing examples of using deep learning to do things we didn't know computers could do. So for example, in the last few months, we've seen computers writing paragraphs of text which humans find more compelling than text written by humans, which until it happened, most people thought was outside of the capabilities of computers to do. Um, and before that, we saw computers recognizing medical anomalies in radiology images better than radiologists could. So like there's all these amazing things that have been happening over the last year or two. The next 12 to 18 months, there's going to be more of those. I don't know what they're going to be exactly, but it's always super exciting to see.
Jeremy Howard always drilling down and focusing on the bigger picture, the things that we need to really think about in this space. If somebody wants to connect with you, Jeremy, maybe they want to find out more about your work, how can they do that?
Feel free to reach out to me on Twitter. I am Jeremy P. Howard.
Sounds good, Jeremy. That's Jeremy Howard, founding researcher at Fast.ai. And if you guys want to find more of my interviews, you can do that right here or go to tonyahall.net. Thanks for watching.